like to start off this lesson by giving a little love to the Department of Defense schools. Every year at Nationals, they come a really long distance just to see me and to participate in the competition. But speaking of the competition, let's get ready for that contest by tackling some counting problems. Now, in our first problem here, we've got 6 different gifts. We're giving them out to 5 different children. Now, we don't want anybody to be sad, not get any gifts, so everybody's going to get at least one gift, and every gift is going to be given out to exactly one child. So we've got 6 gifts, 5 kids. Each kid has to get at least one gift. That means somebody's getting 2. Now, let's see if we can use that to count how many different ways we can give out these gifts. Now, I'm going to use one of my favorite strategies in counting problems. I call it constructive counting. I think about how I could create one of whatever I'm trying to count, and then try to use that to figure out how to count all of them. So what I'm going to think about here is how I would give out the gifts following these rules. If I had to give out these 6 gifts to the 5 kids, everybody gets at least 1. Well, somebody gets 2. I'm going to figure out who the lucky kid is first. So I'm going to look out at those 5 kids. 1, 2, 3, 4, 5. And I've got 5 choices for who the lucky kid is. So I have 5 choices for the lucky kid. Now, once I've chosen the lucky kid, then I have to decide which 2 gifts to give the lucky kid. Now I've got 6 gifts. So I have 6 choices for the first gift, and then 5 choices for the second gift, because once I've given the lucky kid the first gift, there are 5 left. But I have to be careful here, because this overcounts. This counts every possibility twice, because if I gave the lucky kid the big wheel and then the pony, well, then that kid would have the same 2 gifts as if I gave him the pony and then the big wheel. So this 6 times 5 counts every possibility twice. Now, if I count every possibility twice, and I only want to count everything once, there's an easy way to fix that. I count everything twice, I divide by 2, and now I've counted everything once. Now, you might think of this as 6 choose 2, and that's okay. So now that we've given out the 2 gifts to the lucky kid, I've got 4 kids left and 4 gifts left. Each kid gets 1 gift. We know how to handle this. First kid has 4 options. There are 4 gifts left that I could give out. Second kid that comes up, 3 options, because there are 3 gifts left. And the next kid, well, there's only 2 gifts left, so there's only 2 choices there. And then the last kid gets whatever's left. And there we go. There's our answer. Now, we don't want to work too hard when we multiply this out, so we're going to be a little bit strategic here. I'm going to go to 6 divided by 2. That gives me 3. I'm going to multiply the 5 and the 3, and I'm going to have a 15. 5 and the 4 gives me 20. 3 and the 2, that gives me 6. Now I'm going to multiply the 15 and the 6. That'll give me 90. So I'll have 20 times 90 is 1,800. Now, one of the things people find confusing about counting problems is that there's usually lots of different ways to solve the problem. Now, I like to use this to my advantage. And I do that by solving counting problems twice, using 2 completely different methods. And if I get the same answer both times, then I know I'm right. It's the gold standard for counting problems. So here we go. We're going to solve this problem a different way. Instead of picking out the lucky kid first, what I'm going to do is I'm going to go down the line of the 5 kids, and I'm going to dole out 1 present to each. Dole out 1 present to each. And at the end, I'll have 1 present left over, and then I'll pick out who the lucky kid is and give that kid the extra present. So first we'll dole out presents, 1 each to each of these kids. Go down the line. First kid has 6 options. The next one has 5. And there are 4 gifts left, then 3 gifts left, then 2 gifts left. Now I've got 1 gift left over. Somebody's going to get 2. I can pick whichever one of these 5 I want to be the lucky kid who gets the second gift. So I have 5 choices here for who gets the second gift. All right, so now I can multiply this out. I'm going to be strategic again. 6 times 5 is 30. 4 times 3 is 12. 2 times 5 is 10. So let's see here. 30 times 10 is 300. Times 12 is 30. 600. 3,600 is not 1,800. I know that much. So have I done something wrong here? Well, back here I had this little divide by 2 here because I had to account for different orders. Have to be careful. Over here, well, imagine when I went down the line like this, I gave the lucky kid, whoever that turned out to be, I gave him the big wheel first, and then at the end I had the pony left over and gave the lucky kid the pony. But I also could have given the lucky kid the pony the first time through, and at the end had the big wheel left over and given the big wheel to the kid. So this would count both of those as two different options when they're actually the same. The lucky kid gets the big wheel and the pony. So once again, this is all wrong. I have to divide by 2 at the end because I've counted everything twice. Well, I don't have to go through all this computation again. I know that this right here is 3,600. I divide by 2. I'm going to get my 1,800. Now this shows us why I like to do counting problems two different ways. Because if I had done this first, I'd have gotten that 3,600, written the 3,600 down, moved on to the next problem, gotten the answer wrong. But by doing a problem two different ways, I can work through, I can make a mistake on one of them, figure out where the mistake is, I get the same answer in both of them, I'm pretty confident I'm right. So now, I'm really ready to move on to the next problem. Now here we've got one standard 6-sided die, we're going to roll it 4 times. We want the probability of getting exactly 3 different numbers. 3 different numbers. Okay, so we're going to roll the die 4 times. And 3 different numbers, that means, well, one number shows up twice. And the other 2 numbers each show up once. Sounds a lot like that last problem, but all right, well, I'm going to solve this problem 2 different ways, just like we did last time. I'll kind of think of it the same way too. I've got to pick 3 different numbers to be among my rolls here. One of them is a number that's going to come up twice. All right, let's pick that one first. I will pick what number comes up twice first. And I've got 6 choices for that. 6 choices. Number that comes up twice. Now, I have 4 slots for the numbers, so I have to pick what slots will get whatever my duplicate number is. I could put it here and here, or here and here, there and there. Well, I have 4 choices for the first slot, because there are 4 slots, and then there are 3 slots left for where the second one can go. But once again, I have to be careful about order. I have to divide by 2, because I could pick this slot and then that slot for my 4 ways and then 3 ways, or I could pick this slot and then that slot. I still end up with the same 2 slots with the duplicate number, so I have to divide by 2 there. Well, now once I put in the number that comes up twice, well, I have 2 slots left, and they have to get different numbers. I've already used up 1 number, so I have 5 numbers left for the next empty slot, and then I have 1 empty slot left, and I have 4 numbers left to put in there. So that's counting all the number of ways that I can end up with the rolls to satisfy these conditions. So now I can do a little arithmetic here. I've got 4 times 3 divided by 2, that's 6. Got another 6 over there. So I've got 6 squared times 5 times 4. Now I'm not going to multiply this out just yet because I remember that this is a probability problem. Now the probability, this is the number of ways I can satisfy all these conditions, the number of ways I can roll 4 dice. Well, that's just 6 to the 4th. So I'm going to take this. My probability is 6 squared times 5 times 4 divided by 6 to the 4th. I can cancel out a couple powers of 6. Now I've got 5 times 4 over 6 squared. And now my 4 can cancel out the 2 factors of 2 in the denominator here, and I'm going to have 36 divided by 4 is 9, so I have 5/9 as my probability. And you know we're going to shoot for the gold standard here, right? We're going to solve this problem again. We're going to use a different method and hope we get the same answer. All right. What's another method we could use to solve this problem? Now, before what we did is we picked out which number would show up twice and then figured out where it went. Well, instead, let's do something a little bit different. Let's think about the 2 numbers that only show up once. So now the first number that only shows up once, well, I have 6 choices for that. 6 choices for whatever number it is that only shows up once, and I have 4 slots to put it in. So I can put that number in anywhere. So I can put 2 right there, or 3 right there, or 5 right there, or whatever. Now once I've put that number in, now I've got to pick a different number to put somewhere up there. I've got 5 choices left because I've already used 1 number. I have to use a different number now. And I've got 3 slots left because I've already used 1 here. 3 slots left, and have to be careful about that order thing. If I put the 1 here and then a 2 there, that's the same thing as putting a 2 there and then a 1 there. I end up with the same sequence of rolls. So I have to divide by 2 to account for the possible overcounting, well, for the overcounting I will have by doing this. So this tells me how many ways I can put two numbers in this list of 4 numbers here. I can put in 2 numbers, 2 different numbers, in any 2 of the slots. But now I've still got 2 empty slots left, and they both have to have the same number. All I have to do is pick whatever that number is. I pick whatever that number is. I can't use the number I used here or the number I used here, so I have 4 left. And that's it. Once I choose that number, I just put them in those 2 empty slots, and I'm finished. So now we just need to compute this. Let's see here. We got 4 times 3 divided by 2, that's 6. So we have 6 squared times 5 times 4. And that's exactly the same thing we had right here in our numerator, so we're heading to get exactly the same answer. So we've hit it. We've hit the gold standard of counting problems right here. Now I want to take a step back, look at these 2 problems real quick. Look at that computation, multiply a bunch of stuff, divide by 2. And then we look back at the computation we did here, multiply a bunch of stuff, divide by 2. And even the stuff we're multiplying looks kind of similar. These problems even feel a little similar, right? So maybe they're actually the same problem, but just with the numbers changed a little bit. So here's your homework. I want you to think about this problem, and then think about this problem, and see if you can explain why these 2 problems are actually exactly the same problem, just with the numbers changed.